I thought it would be really great to review about your immune system and then what does a 72-hour fast have to do with your immune system. I really am trying to tie in what happens in your immune system and what happens during a fast, but what would it benefit you? And by you, I do mean the people of the world trying to fight through what I think is going to be a higher level of this coronavirus in our communities because of the opening up of the population. So this is what I'm telling my patients, and this is what I'm telling my people. So what this study was looking at is that there are several studies that have come out since the last time I talked about this that look closer at what happens when ketones circulate within our body. I am going to try and scroll through this with you a little bit because I really think it's worth just spending a little bit of time on. So it talks about this receptor called HCA2 and how the inflammation inside the human brain has messengers specifically that are related to BHB, or that's the chemical name for ketones. The neuroinflammation is a pathology common to many neurological diseases, including multiple sclerosis, stroke. Other things that are listed in the study are Alzheimer's, Parkinson's, ALS. And they're looking at this neuroinflammatory cell with the expression of a special receptor called an HCA2. This is neuroprotective, the receptor for the endogenous neuroprotective ketone body, beta-hydroxybutyrate. So when we produce ketones, we know that there is an increased signaling from these ketones that bounce around our system outside the cell, like that PMN is outside the cell. So is a ketone. And this study really looked at discussing the mechanism and the benefits for the neuroinflammatory diseases that are therapeutic and potential for protecting our bodies. As we look at this, I quoted this study about a month or two months ago, maybe now, looking at the ketogenic diet, which activates some of these, that T cell or those PMNs, which I know those are lots of lingos that many of you might not know about, but really it's what your immune system uses to talk to our cells. They're very hidden, they're hormones, so they do goofy things that are hard to say, Doc, I want a blood test of my immune system. You know, I saw this podcast about cytokines, can you check my cytokines? And the answer is no, we can't do a blood test to check your cytokines. But as we study the cytokines and we look at how our white blood cells function, we've learned that when a ketogenic diet, a state of ketosis, and this is really important as I look at the students I teach, that we don't just talk about the food you eat. Ketogenic chemistry isn't just food, it's what's happening on the insides of your body. It's not an accident that every time I try to start this show, I poke my finger and show you my numbers. The discussion further inside this study looks at that the ketogenic diet in mice was found to be protective against influenza viruses. That isn't such a little thing when you get deeper into the process of how well your system responds to a problem versus how much it overreacts to a problem. It can be difficult to measure that. As a physician, when patients come in and ask me for help, these are one of the backstories that I'm thinking about. If their body is under attack, if I offer them chemotherapy, how fragile is that system? How well will it respond? If they have a mini stroke, how many brain cells would die? So you look at the ketogenic diet and the state of ketosis, which is actually much more important than the ketogenic diet. The fact that your system is in ketosis and how much that protects you against infection because of how your cytokines are working. Now, that doesn't mean you produce ketones for one day and you're going to have this protection. Looking at this study, this is the one I was scrolling through with you. This is where these ketone bodies, the beta-hydroxybutyrate, are an endogenous factor protecting against stroke and these neurodegenerative diseases, but it also it works to protect them by looking at their immunity, looking at their macrophages, looking at those class of cells like that PMN was on the outside of the cell, talking to those cells, communicating, hey, we have a problem. If you go back to look at that slide, you'll see that there was a COX-1 receptor. You're going to see, if you look deep into the study, it talks much more about the cytokines coming from your monocytes, and that your macrophages are really important for not only signaling your brain, but really understanding your system. So I've shown you this before, but I like you seeing this this cell that's kind of bumpy, and it's got the blue things on the inside, and it's got that beautiful nucleus on the outside. It's a macrophage, and macrophage stands for eating another cell. So it's eating an infected cell there. So if you look really closely at that red cell, you can see some white ticks on the inside of the cell. That red blood cell is what they're using. It's not really a red blood cell, but they're kind of shaping it like a red blood cell. So it takes that cell all the way in and it bites it up into little bitty pieces. It presents those little bitty pieces from the infected area to the outsides of this macrophage, and that sends these signals from one cell to the next. This is where your body does some really cool things, and most people never know this is happening. We're very thankful when T cells work, because once they're activated that, hey, we have a problem, this is the invader of the human body, we need to make some of these cells into a army protecting us. Those T cells, once they know what the enemy looks like, once they have those little red spots in the cell, they will replicate and say, all right, army, I need you to take the receptors on the outside of our cells, go find the matching components to this cell. So when we make a vaccination, we often use these types of communications that your body already does naturally. So they find this is a cell, those little white things, I made them more enhanced because they're kind of hard to see, but those white things are infection. So this is an infected cell, and those red bumps on the outside aren't necessarily the infection, but it's the markers of the cells that say, hey, this is what the cell looks like. So we're just kind of enhancing those red spots there. Now that the T cells are on the march to look for these cells, they find the infected cell. And this is where cytokines come in, because that T cell now starts to spread the message outside of our cells. It spreads it like in a hormone, almost like a ghost whispering between cells. Hey, this is the enemy. This is the enemy. Come attack the enemy with me. And as the infected cell gets pummeled with cytokines, it kills the cell. It causes apoptosis, or cell death. So these cytokines are really awesome. And with the world of coronavirus, you've probably heard of the word, maybe you've heard of cytokines. Cytokines are where this coronavirus, but where lots of infections have their biggest enemy, and that is when it activates cytokines, it causes an inflammation. It causes the body to respond. I don't know if you can see the little white tags I've got in the cytokine parts, which is IL-13, which stands for interleukin, interleukin 13, interleukin 10, interleukin 6, 5, and 4. These are just names of different cytokines. And in our people that are suffering from the most mortalities and morbidity, the most trouble from coronavirus, is because they overproduce these cytokines. As you watch that human body see the enemy, and where is the enemy coming in from? It's coming into their lungs. But their cytokines aren't as healthy as they should be.
Please subscribe to my channel. And don't forget to click the notification bell so you don't miss out on any new videos. Stay tuned.